In this lesson, we're going to look at the different ways to factor and solve polynomials. So there's four main ways to factor a polynomial, and you want to make sure you can remember how to factor quadratics from the last unit. The first way will be the GCF, then we'll talk about grouping, quadratic-like, and then sum and difference of cubes. Now before we get into each of these types of factoring, it's very important to remember the difference between factoring and solving. So it seems easy enough, but a lot of times when a question's asking to be factored, I've seen a lot of people go ahead and finish solving it or use the quadratic formula instead of factoring, so we want to make sure we understand the difference. You know you're going to just be factoring if there's no equal sign in the equation. You'll just leave your answers as the factors, so if the question was asking you to factor this, this would be your answer. For a question that you need to solve, it will have an equal sign. You'll factor and set the factors equal to 0, and then you'll solve for x. And then this piece right here is very important. The number of solutions you get should match the degree of the polynomial. So if your degree is a 2, meaning it's a quadratic, you will have 2 answers. If you have a cubic with a degree of 3, you'll have 3 answers. Quartic, degree of 4, you'll have 4 answers. So here, same problem as before, except there's an equal sign in it, meaning that we're going to have to solve for x. So we go ahead, set it to 0, factor it, set each factor to 0, and we get our 2 answers for x. So the first method we're going to look at is GCF. So we have to factor out the greatest common factor from the polynomial, and then we want to check if the polynomial factors further. So when we look at this first example, there's no equal sign, so all we're going to do is factor it. So we're going to look for the GCF, which is 2x, and then we're left with x squared minus 5x minus 6. Now what's in the parentheses is a quadratic, so we want to see if that can factor further. So a is 1, so we're going to come up with two numbers that are going to multiply to -6 and add to -5. And that's going to be -6 and +1. Since the a value is a 1, we can just use our shortcut. So we have x minus 6, x plus 1. And since our 2x was what we pulled out from the GCF, we're just going to make sure we put that back in front. And this is fully factored. So once you get it down to a linear, you know you're good. If you have a quadratic, we just have to check if it can factor further. In number 2, we do see an equal sign, so that means that we're going to have to factor it and then solve it for x. So again, we're going to look for a GCF first. Here we have an x as the GCF, so we have a 2x squared minus 7x plus 3. What we have inside, again, is a quadratic. Since a is not 1, we're going to multiply a and c. So we have to come up with two numbers that will multiply to 6 and add to -7. So we're going to use -6 and -1. Since a is not 1, we have to do this the longer way. The x that we took out as the GCF, we're just going to ignore it for right now, and we're going to bring it back at the end. So we're not disregarding it, we're just going to leave it alone for the moment so we don't get confused. So we'll bring down the 2x squared. This should be equal 0. Bring down the 3. And then we're going to rewrite the -7x using the two numbers that we have. So -6x minus 1x. Okay, we have 4 terms. We've expanded it, so we're going to group the first 2 and group the second 2. Pull out the GCF from the first grouping. That's going to be a 2x, so we're left with x minus 3. Pull out the GCF from the second grouping. That's going to be a -1, and we're left with x minus 3. Remember that when we do this, we should have the same numbers in the parentheses, and we do. They're both x minus 3. So we're going to take the two outside terms and put them together, 2x minus 1. The two that are the same, we have x minus 3. And now we can't forget the original x that we took out in the beginning, so we'll put that in the front. And then this was equal 0. So if the question was just to factor it, we would leave it like this. Since we're solving it, we're going to set each of these to 0. So we have x equals 0. That's one answer. We have 2x minus 1 equals 0. So we add 1. 2x is equal to 1. Divide by 2. Whoops. So we get x is equal to 1/2. Okay, and then we have x minus 3 equals 0. And x is equal to 3. So our original problem here had a degree of a 3. So that means that we should have 3 solutions, and we do right here, 1, 2, and 3. The second method we're going to look at is grouping. So when you have 4 terms, you want to factor the polynomial by splitting the terms into 2 groups. So we pretty much did that in the last example where we created 4 terms, but here we're going to start out with 4 terms. Okay, so when you see any type of polynomial to factor, the first thing you should always look for is a GCF. That goes for when we were factoring quadratics. Anytime we factor, look for that GCF first. If you see 4 terms, we should use grouping. So all we're going to do here is group the first 2, group the second 2. Okay, again, notice number 1 does not have an equal sign, so we're not going to solve it. All we're going to do is factor it. So we're going to take out the GCF from this first grouping, which is x squared, and we're left with x plus 3. We're going to take out the GCF from the second grouping, which is negative 4, and we're left with x plus 3. Again, these should match, and they do. So we're going to take our 2 outside terms and put them together. That's x squared minus 4. 2 inside terms, count it once, so x plus 3. Now we have a quadratic, so we want to see if we can factor that quadratic further. X squared minus 4 is difference of squares because both the x squared and the 4 are perfect squares, and there is a minus sign in the middle. So we're going to take the square root of each, so we get x and 2, and then we write our answers as x plus 2 and x minus 2. And then the x plus 3 just stays as is. And we were just factoring it, so we're just going to leave it like that as our answer. In number 2, we have an equal sign. So that means that we're going to be solving. In order to factor this, the first thing we have to do before we can factor it is make sure that it's set equal to 0. So we're going to add 8 to the other side. So we have x cubed plus 4x squared plus 2x plus 8 equals 0. Okay, so we see those 4 terms. That indicates we're going to be using grouping. Take out the GCF from the first grouping. That's going to be x squared. So we have x plus 4. GCF of the second grouping is going to be a 2. We have x plus 4. And again, we have the same factors on the inside, the x plus 4. So we take our 2 outside terms, x squared plus 2. And then we have the x plus 4. Now we'd see a quadratic again, so we want to see if we can factor it. Right? X squared and 2, well, x squared is a perfect square, but 2 is not a perfect square. And there's a plus sign instead of a minus sign, so we can't factor that any further. So this would be fully factored, but now we want to go ahead and set it to 0. So if we take, we'll start with the x plus 4. If we set that to 0, we're going to get x equals negative 4. And then if we take x squared plus 2 equals 0, subtract the 2, so x squared equals negative 2. And then we have to take the square root. So when we take the square root of anything, we get plus or minus in front. That means that there's 2 answers here. The square root of a negative means that we have to pull out an I for imaginary. And then what's left over becomes positive, what was inside, the 2. And then the 2, we want to see if we could break that down using the prime factorization trees, but we can't because 2 doesn't break down and there's no perfect squares in 2, so we leave that as our answer. So this should have, based off of the exponent, 3 solutions. We have 1 here, and this plus or minus counts as 2 solutions. So we have negative 4, positive I root 2, and negative I root 2.